Hello, my name is Xenophon Babadimitris. I'm a professor of biomedical informatics and data science here at Yale. This is part of a series of interviews we do for our educational programs here as supplements to that. Our guest today is Ian Sutcliffe, who is a principal solutions architect at AWS, the Amazon Cloud Services company. Proud that he has many years of experience in the health science sector, in tech, in various software roles, developer, an architect, a solution and business architect. And, Ian and I got to meet virtually as part of this AAMI committee to develop guidance for the use of public cloud services in medical devices. So we're going to have a chat about clouds and medical devices and how the two play well together or don't play well together, where we can and can't use them. So Ian, welcome. Just tell us a little bit about yourself and what you do, and we'll go from there.
Great, thanks. Yeah, first, thanks for letting me talk to you today about, well, wherever we go. I'm a generalist at heart. I cover many topics. As you mentioned, I currently work for AWS. I've been here a little over 5.5 years. I realized recently that I'm old, so I've actually been in the industry, the IT industry, for a little over 30 years now. Started way back when e-commerce was a new concept back in the UK. So after my degree in computer science, I moved down to London, created a startup, created a web development platform running on NT, which was when dynamic web pages were a new concept. So it's been a long time. Since then, I've stayed in IT. I'm a techie at heart, but I've moved from, development roles to solution architecture roles to business architecture roles, enterprise architecture roles. You name it, I've probably done it. So yeah, I'm a generalist. A lot of my time has been in life sciences, so both pharmaceutical industry and medical device industry. So I spent a lot of time dealing with regulations and trying to push the envelope from a new technology perspective, bringing those new technologies into this regulated environment. So it's been an adventure.
So let's start, and we had a discussion before, let's think a little bit about the day in the life of a cloud provider, right? So pick a service, however you want to do it. Pick one that maybe is more related to medical devices. Let's think, how does it start, how it evolves, how does it get used? What do we do here?
Yeah, it's an interesting world, and certainly, at AWS, we always, like to say we work back from the customer. So what is the need? And we create services or service features based primarily on customer feedback. Occasionally, we'll invent something because we think people will use it, but the majority of the time, we're actually working back from customers. And it's a different world when you're working within a cloud service provider because scale is so different. I've worked in big IT organizations, but they are minuscule compared to the big cloud service providers. So, you get this idea usually from a customer for a new service. It goes through, initial reviews, approvals, people think it's a good idea. And then it goes through that design process, and it has to be designed to that certain level of scalability, resiliency, and availability that is far beyond, my experience prior to AWS. Cloud scale is just at a whole different level. New services, we will typically then, go through that initial build. We will build out what we call a minimal lovable product. So not a viable product, but a lovable product. It's enough functionality that you can really get a feel for what the service is doing and really start to support real life use cases. It'll go through beta testing with customers, then it'll go through general availability, get released. You'll often see it announced at the big conferences like reInvent. And then, it will typically be covered by certain compliance programs initially at GA, but then, of course, that it will get added into different internal compliance programs, which is an important aspect from a medical device perspective, because that's one way that customers can start to assess this shared responsibility model. And does the cloud provider have all their IT controls in alignment and to their needs? And then the service drops, into, steady state. It gets enhancements. We may add features, again, based on customer feedback. It's improved and changed over time. Hopefully we're, the objective is to continually improve these services until it's ultimately retired, if it's ever retired. So that's a typical life cycle of a service, I would say.
So what are some of them? If you give a couple of examples of type of services that are popular in this industry, in the medical device industry, like what are some of the most common ones typically?
Yeah, I mean, so compute services like EC2, so your virtualized servers. I always use S3 as an example. It's just a object storage service, but I love it because the concept is very simple. But when you consider the architecture behind it, it's quite amazing when you actually see or start to understand what's under the hood. So S3, it's just a simple storage system. You create what you call a bucket, and then you put your files or objects into it for storage. Sounds very simple. You just upload, download objects. But that service has something like 11 nines durability, which means, it will lose potentially one object in every several billion. I forget what the number is. So it's extremely resilient. So when you do that simple operation of uploading an object into an S3 bucket, it's behind the scenes replicated across multiple what we call availability zones. You can oversimplify, but consider that different data centers. And each of our regions has at least 3 of those. So your object is replicated across 3 data centers immediately. That's transparent, doesn't affect performance, it doesn't affect cost, but it allows us to meet that durability SLA. So it's just an example of a simple service, but operating at cloud scale, you start to get to see the difference. That kind of capability, those durability statistics, you would struggle to do on premises. I mean, I've tried. It would be hard to do, but that's a very simple service, and that becomes critical in kind of these regulated industries where data integrity is important. So that ability, that assurance that that data is not going to get lost is an important feature. So I kind of like that one because it's a simple service, but under the hood, it's very complex and quite impressive.
Yeah, I mean, the best software does something complicated
Yeah,
and appears very simple to the user, right?
yeah,
So but again, you guys are running this at cloud scale, you're making improvements, you're changing things, presumably. So how do manufacturers, how should they deal with these changes in cloud services? You're always changing features. And that is at the heart of the TAR in some ways that you're working
yeah.
on.
Yeah, and I think it's important to understand the type of change. So, in the medical device industry, it's all a risk-based, risk management-based approach. So, what is the risk of change? Um, Simple one, net new features. It's inherently low risk because it's new. You're not using it yet, so it's an easy adoption. Uh, Other end of the scale are deprecations. So that could be service deprecation, feature deprecation, or even what I call just runtime deprecation. So perhaps you're using a certain version of a database engine, Postgres, SQL, particular version. Over time, those things do go out of support. So we'll want you to upgrade. Similar with Lambda functions. If you're using Node.js version, I don't know, 15, I think we're on version 21 now. So there is this change from that perspective as well. But you will get sufficient notification when there are those kind of deprecations. And so it gives you time to deal with it. But the majority of the change that's happening is small incremental changes geared to fix bugs or increase performance, improve the service as a whole. And those are happening all the time. And this is kind of where manufacturers get a little nervous because change is now a constant. It's happening all the time. And you're not necessarily, you don't know about it. So even if we were to issue notifications of every change, what are you going to do with that flood of information? First, you'd have to filter out, okay, which ones are actually relevant to the services I'm using? Do they affect me? It's impossible to deal with the amount of change that's happening. So manufacturers just need to figure out how to manage this within their existing ways of working, their quality management system. And it's part of the supplier assessment as well. So manufacturers need to have confidence in their cloud service provider. How do they deal with change? So as part of that supplier assessment, any insights you can get into how this cloud service provider is managing that change gives you confidence, helps you address potential risks. Hopefully the changes are all small because a lot of small changes are actually less risky than one big change, because if there's a small change and there's something going wrong, you immediately know what you have to roll back. Insights into how changes are released is important. So, not only is it the internal testing that we're doing of the service in our test environments, and I'll mention we don't just have one test environment, we have alpha, beta, gamma, different configurations. But even on release, changes are small. They're released to a single or a subset of machines in one availability zone. If there's no adverse effect to that, then we expand that to more machines, to the availability zone, to the next availability, to the entire region, and then repeat for the next region, the next region. So it's a very gradual release mechanism. And at any point, if we see any form of regression, it gets rolled back. So there's continuous testing happening all the time, not only during development, but during release and into production, which is a new concept for a lot of device manufacturers, this idea of testing in production.
And I guess that's exactly where the manufacturers themselves have to land when they're using cloud services. Right? How do you test in production in some ways your devices as well, which is a touchy issue for
Yeah,
many of them. But if you're relying on a changing world that's always being tested, is your medical device static anymore? Or do you now, how do you test, how to ensure that the small change, because one of the things we all learn in software is that sometimes your software works for the wrong reason. And now the bug gets fixed on the other end, and now it stops working. And it should never have worked, but now really doesn't work, right? So how do you ensure that that's not the situation? So what are your recommendations for people to think about testing and ensuring things that rely on these cloud services still work, essentially?
Yeah. Manufacturers should definitely continue to follow industry best practices when it comes to testing. So, the traditional unit test, integration test, hopefully all automated. I think automation is key. What we're seeing is the cost of testing used to be very high because it was very manual. So a manufacturer would go through, build a device, go through formal validation. It was often very manual testing. That's a costly way of testing. The more you can automate, the more you can drive that cost towards zero. Now, you'll never reach zero, but you're driving it down. It's getting cheaper and cheaper. So if testing then is, automated, you can do that after every change that you make to the device. There's little cost. There's no downside to running a full regression suite of tests off after you make any change to your medical device. But the change is also happening to the underlying the computing environment within which your device is running. So the question is, should device manufacturers start to test in production? Typically, it's device manufacturers would wait for some kind of report from the field that something's wrong. Now, I think the best practice is shifting, and this is common, across all different industries that are operating in cloud, is you can very easily spin up an environment that mimics your production, execute tests, see if there's any regression, and tear down the entire environment. So the cost of testing again is, and the cost of the test environment is being reduced over time. So I think that these new best practices around actual testing in production is becoming commonplace.
And obviously, it's going to be more important when your risk level is a little higher, right? You can't just wait to hear from the audience. In the notes here, when we're talking, you talked a little bit about them as distributed systems, right? So, and this is true in a hospital environment as well. We think about cloud, but your EHR is part of your device. Your PACS database is part of your device. So, how are we thinking about distributed systems and cloud services and all of that? And I guess just to tie you a little bit more.
Yeah, it's an interesting dynamic because you talk about cloud and then, this idea that, oh, well, part of the functionality is running, in this nebulous cloud system. It's really somebody else's data center. But that's been the case for distributed systems forever. So as soon as we had a front end and a back end and connectivity and communications between the two, we had the same kinds of problems. So, you'll never be able to stop somebody, digging up the road outside your hospital and severing your internet connection. Those things will still happen whether you're on-premise data centers or in the cloud. So this perceived risk of cloud really needs to be, as the FDA likes to say, some critical thinking needs to be applied to. Is it really a cloud-based risk, or is it just a distributed system risk that's been there all the time? Then also start to consider some of the benefits of cloud. So I mentioned, with that S3 service, the durability, the storage, what's happening behind the hood, the ability to build those same kinds of capabilities on-premise. It's rare that I've seen anybody do that. So there's benefits to cloud as well. So then you get into the risk benefit of this distributed system sitting in cloud, but with the benefits of the cloud resiliency, the service designs. So it becomes this kind of balancing act. Does the benefit outweigh the risk? And that goes again for the change, the fact that change is happening, but does the benefit of using these cloud services outweigh the fact that these, constant stream of change is happening?
Right. In some ways, the analog here is a lot of what we're seeing on the cybersecurity side, right? I mean, sure, theoretically, your software running on Microsoft Windows is not a distributed system, but 3/4 of the functionality is inside Windows. And Windows changes, it's the same story, right? The fact that there's not a network connection between you and Windows doesn't mean that you control the changes on that end, or you control what Microsoft has done and how we create this. So in some ways, what I found interesting as I got involved in this cloud war is how much it revealed about the rest of what we do, right? Like, because we control very little. You're running a browser-based application. Well, how often does the browser change? Like 90 days, 60 days? What's the current update cycles, right? So but there's a benefit to it changing, right? If you don't update for security, you're going to have a security hack before you know it, and you wish you had changed it. On the other hand, you have to juggle that. So I guess one more topic is, okay, so now let me put my software engineer hat on here a little bit. So, okay, so I have these distributed systems, I have this complex universe, I have cloud services, maybe I have operating systems I don't fully trust. How does that change how I design things from, my static world where I downloaded that library once, tested it, and said, okay, certified, good, I can now use it.
I think we're in a world where there is more and more distribution of the components of any medical device system. So if we look at it as a whole system, and then there's parts of that system that are providing medical function, they're important pieces. There's lots of pieces that are less critical to the functioning of this system. So, let's take an example. You have a physical device in use in a hospital. It has firmware installed on it. It's often now connected to the cloud. It's streaming data to the cloud. You have a data repository that you're building there. Then that's supporting potentially a decision support system, or its data is being used for machine learning purposes. You've got a lot of pieces to a single system. But the regulations that apply to those different parts is now different. So you've got 62304, you've got the actual medical device itself and the functions within it providing medical function. That's important. That's of a focus to regulatory agencies. But its connectivity may be classed as a medical device data system, not as regulated as the device itself. You have data being stored in a data lake or some form of database. It's not directly regulated, but data integrity, according to 21 CFR Part 11, is important when you have this kind of data sitting there. And then depending on its use, it may fall under different regulations. So it could be used for, in the pharma world, GXP purposes, in which case it's subject to computer system validation. It could be an ML, which in itself produces a medical function. So now you're in software as a medical device. So if you think about each of these pieces, I like to say you can draw compliance boundaries around pieces of your architecture. The whole thing will appear in a submission to a regulatory agency, but their focus will be on the pieces that actually provide medical function. So how you deal with these different pieces starts to change, and you don't treat the whole thing as a monolith anymore.
And I guess you explicitly design it as not a monolith by having nice walls between the pieces so that you can survive one the other in some ways too.
Absolutely. You want those nice defined interfaces between the pieces. Because various pieces will also follow their own life cycles. So the device at the edge may be fairly static. The machine learning model at the other end may be very dynamic. So each piece is following its own life cycle. The documentation sets the evidence that you have to upkeep. You want to be able to rev this piece over here without having to touch this piece. So a lot of reasons why we want to try and break this architecture into its pieces. So from a systems engineering perspective, there's a lot of benefits to breaking down this architecture.
And again, I can't help but think that that's the same situation with dependent libraries in a large project, right? You don't want to call them from every line of code to have a call to this library. You want to sort of silo that call and say, we're calling our database from this module in our software, so we can change that out, right? It's the same story again.
Absolutely. That idea of compliance boundaries, not just breaking down architecture, but within the device to the software modules. Certain functions within the device boundary will be of particular interest. They provide a medical function. If it's like a device and one of those software functions is just changing the screen color, you really don't care too much about that. But yes, understanding the dependencies between the modules and those shared libraries is important, because if you change that shared library, is there a dependency to the software function of interest? So yes, it's all same concepts, different scales.
Yeah. So I guess the last topic we had here was, okay, so you have an existing medical device, it's using on-prem servers, and now you're thinking about migrating to a cloud. How big a change is that? And I'm sure people come to you all the time with that. That's like, I'm sure, one of the standard cases.
Yes, it is. And again, it's a very interesting topic and a discussion I have with many customers. Now, I'll preface this with I cannot give regulatory advice, but if you think about it, let's say you have a decision support system, it's sitting on a Windows server in a hospital somewhere, and you move it from one server to another. Is that a big change? Not really. Doesn't really impact the functionality of that software. Let's say you move that from one data center to another. Same kind of servers, same operating system. Is that a big change? No, not really. In recent history, there's been a big move to virtualization. So if you take that and you virtualize it and run it on something like VMware, is that a big change? Again, fundamentally, there's been no code change. It's all the same libraries. It's the same operating system. So it's not a big change. If you think about a move to cloud, you're basically combining all of that. So you're moving it off physical infrastructure, you're virtualizing it. You're also moving data center, you're moving into ours, not yours. Is that a big change? So a lift and shift of these workloads to cloud is really just changing the environment within which it runs. You've not changed any code, no libraries, no dependencies. Even the operating system level hasn't changed. So in my view, from a technologist perspective, moving to cloud in that case is not a big change. And of course, a lot of people would disagree with me, and there's changes to the security and risk profiles, but on a whole, from a technology perspective, it's not a big change.
Right, but it's a visible change.
It is a very visible change,
in a way
yes.
that it was not visible before, right? Then that's, and to me, that's actually what I'm really interested in many ways, because when we talk about the cloud, it reveals issues that were always there, but they were never visible.
Yeah.
And now, because it's visible, there's a communication line that lifts some box. Now we realize, oh, that communication line is really important. Well, it was always there, but now it's exposed. And so now we need to deal with it in a different way. So, yeah.
Yes. Yes, and I think it means people are revisiting some of the regulations, and again, they're trying to analyze, is this actually a significant change? Is it going to affect the medical function of this piece of software? Yes or no? And a lot of times the changes to the underlying computing environment, as 62304 stated, does not directly impact the functionality of the device itself. And I think people are kind of starting to revisit those, or going back to those old terms and definitions, because of this move towards cloud.
Mhm. Ian, we've gone for a while. I don't have any more questions. I mean, we can talk forever, but I don't have any more immediate questions for you. Is there anything else? So if you're a student, you're trying to get started here, or you have any other thoughts for people as we close as to how they learn more, or what?
I mean, there's a lot of resources out there, especially around cloud, a lot of free resources. So if you have an interest in, building cloud-based solutions, then there's a lot of resources there, a lot of training. We have certifications. I would encourage anybody just to go out and search for any free training. It's any topic from, not just medical devices, but maybe even more current topics around machine learning models as software as a medical device, the big wave of generative AI and large language models. Lots of resources in there. So there's plenty to keep you busy and keep you interested.
Okay. Thank you for taking the time.
Welcome.